All right, let me spend a few minutes just talking through this handout here. We've solved differential equations before. That's when we change the y prime to a dy dx, move the dx to the other side, and then we integrate both sides. And then you remember your plus c, and then you're done. Now, in the past, we had nothing but x's over there with the dx. Now, what we're going to learn in this section is when you move the dx to the other side, there's going to be a combination of the x's and y's. That's why it's titled separable differential equation. So here's what we're always going to do. Anytime you see the y prime, that's the derivative. You're going to make that dy dx, multiply both sides by the dx. And then what you're going to do, those are the differentials. You're going to lock the dy and the dx in the place. You don't want to ever have a 1 over a dy or 1 over a dx. So you're always going to lock those differentials into place. And then what you want to do is always get the y's with the dy, x's with the dx. If you have any extra numbers, it doesn't really matter whether I move the 3 over here or whether I leave the 3 on that right-hand side right there. But you got to get the y's with the dy, x's with the dx, right? And so that's what I'm going to do here. I'm going to multiply both sides by that 3y squared. And then once you have the y's with the dy, x's with the dx, you're going to integrate both sides. Once you integrate both sides, you're always going to put a plus c. Instead of wasting time and putting plus c on both sides, I want you to always put the plus c on the side the x's are on. Like technically I could put like a c sub 1 here and a c sub 2 here, and then when you move them over, it's one big giant c anyway, so it doesn't matter. So we always want to eventually get the y by itself, and so you always want to put the plus c on the side the x's are on. So just integrate both sides, remember your plus c. And then in this section, what we're going to struggle with sometimes is just how to write the answer, how to simplify it after we integrate it, because there's a couple weird things that happen there. So that's why I'm going to attempt to show you here. But there's nothing new in this section. I mentioned you already know this stuff. There's nothing new in terms of, hey, this is a brand new thing of how to integrate it. You already know how to integrate every single thing in this section. We're just going to practice separating the variables. So there's usually a couple steps in the beginning, and then at the end, a couple weird things happen on those problems here. I'm pretty sure the next few examples that are on this handout are actually homework problems from the worksheet that I'm going to have you do there. So the point is I try to give you one of each kind here of something weird that happens. And then I want you to kind of model that, practice on that problem. And then there's going to be at least another similar scenario on the homework where you could practice all by yourself there. But you are expected to do all those problems on your own. If you get stuck on one of these problems, you can go back and take a look at what we did and what we talked about right here. On all these problems, we want to typically get the y part by itself, like y equals something. For now, it's going to be okay to have y squared equals something or y cubed equals something, okay? But if we have an ln in there or an e function in there, we need to kind of make sure we get y equals something, right? Now, we'll talk about this little box in a second there. So at the beginning, all right, I make that y prime a dy dx, and then I move that to the other side, just added that over there, multiply both sides by the dx. Okay, if you want to flip the two sides of the weight bar just to have that dx on the right, the dy on the left, like we're comfortable with, we can go ahead and do that. But notice that I got the y's with that dx. I got this x with the dy. We need to separate these variables right here. So you're going to just do legal algebra, divide both sides by the y, divide both sides by the x, and now I have y's with the dy, x's with that dx. Now we're going to integrate both sides. When you integrate 1 over y, you get the ln of y. This is a simple u du. You see my work right there. And then I notice I put the plus c in there immediately. Put the plus c in there right after you integrate both sides. Put that plus c in there right away on the side the x's are on. And then right here, you see how I have the ln of y is equal to something? So if you have the ln of y is equal to something, we need to get the y part by itself. So you're going to use that main definition of your log, right? If you have log base b of a equals c, you can rewrite that as b to the c equals a. And so that's what I'm utilizing right here. I'm going to go e raised to that whole thing where that plus c is already there because we integrated it, right? Where that I'm going to go e raised to that whole weird thing equals that y part. Now there I have the y by itself. So if I'm giving you an assessment over this, I would count that as full credit. On an AP free response, they would count that as full credit. Sometimes on the multiple choice, what we're going to have you practice here is just a different way of writing these answers. When you check your answer key for this homework there, I'm going to have this thing listed. So I want you to just show you where those are coming from. So what this is attempting to do is right here. If you have y equals e to the x plus c, and that c is in that exponent, you can rewrite that as e to the x times e to the c, right? Because if you went from the second step to the first step, you would have the common base, you would just add those exponents up. But you know what e to the c is? That's just some number. That's a constant. Well, that's one big fat constant. And so you could just write that as one big giant C. And so that's why when you have that scenario, that's where that C ends up in front, because it's just representative of a constant. And so that's why I did e to that, and then that's one big constant. So you could write that as a giant C. That's just another way that you could write that. So that's really the new stuff, is just that weird thing that happens right there. And then something else weird is going to happen on this problem here. So notice the first thing I'm going to do is make the y prime a dy dx, move the dx to the other side, and I got to do legal algebra to get the y's with the dy, x's with the dx, right? And so I get that, and then that's an easy ln, that's an easy u du with getting an ln right there. Now here, when I'm trying to get this y by itself, see how I have an ln on both sides? Let's take a look at this guy right here. If I have, if I have y equals ln of x plus c, one thing that we could do in the future, that's not even like this is part of this problem there, but if you have y equals ln of x plus c, you know what else is a constant? Is the ln of c is a constant. So if you squeeze in an extra ln right there, then you can use your pre-calc properties. Now the ln of a plus the ln of b is the ln of a times b. So if you had a plus c, you could put an extra ln in there, and then you can use your pre-calc properties where that c ends up in that guy right there. Right? So sometimes we'll just need to do that. Now right here, if I have an ln on both sides like this, what I could do is I know I can use my pre-calc properties. I can move that 3 up there like that. And then I'm going to do what I talked about up here. So I have the ln of something plus c. And then so I could just squeeze in an extra ln right there. And then I can use my pre-calc properties to multiply those two things together. And now if you have the log of a equals log of b, the logs could just drop off and you got a is equal to b. And so that's why I'm doing that approach, because I had log on both sides. So I was trying to work in that scenario. And that's why I put that extra ln in there, and then you did that. And then now once you have the log equals a log, then the logs can just drop off. And then you got that y part by itself right there. All right, so those are the two weird things that kind of happen that are kind of that we're not used to doing. But the whole beginning parts of the problem, the first few steps where you're separating your variables and you're integrating both sides, remember in that plus c, that's stuff that we already know how to do. All right, so the biggest thing is on the AP test, when they say solve a differential equation, we sometimes don't have to worry about some of that weird stuff so much on an actual AP test. Sometimes we do, sometimes we don't. We'll just practice it just in case. But most of the time, they give us a pretty straightforward differential equation where their integrals themselves are pretty straightforward. But a lot of times they do love these differential equation problems with the e's and with the ln's. And so that's what this worksheet will just get us some practice doing. We'll practice separating the variables. We'll practice being uncomfortable with the weird stuff going on right there. But the main thing is we're practicing separating the variables and practicing with their integrals with the e's and with the ln's right there. Just whenever we see a differential equation, when we do the AP review, you're going to hear me say this a lot. That's when we're going to get the y's with the dy, x with the dx. We're going to integrate both sides. We're always going to put the plus c on the side the x's are on. And then if they don't have numbers attached, then we're just going to stop here. This is what they call the general solution to the differential equation. And then the last example we're going to talk about, if they say find the particular solution to the differential equation, they're always going to give us a given point. They'll call it an initial condition quite often. And then we're going to use that point always. I'll plug it in to figure out what that C value is, right? So this is the last example. And here's the directions. Find the particular solution to the differential equations that satisfy this initial condition. So they give us this. This integral is really, really simple. The nice thing is, some of you are wondering, why are you allowed to just stick an ln right there? Why are you allowed to do this or that? I'm going to show you like 3 different ways of doing this problem, why it doesn't matter what, as long as you get that plus c in there instantly right after you integrate. Like if you forget to do that plus c and then you start doing the couple algebra steps and then decide to put the plus c in there, it's going to be wrong. All right, so as long as you integrate both sides and stick that plus c in there immediately, then do the stuff I'm asking you to do, it's going to work out just fine. I'm going to show you why it doesn't matter, why we're allowed to do the things we're doing, even though it seems a little bit weird when we're given a point. I'm going to show you 3 different ways to do this problem, how we're going to arrive at the same answer every single time, right? So the first thing I'm going to do is make that y prime a dy dx, move the e dx over, multiply both sides by the dx. Nice thing on here, the variables are already separated for it. So I got the y's with the dy, x's with the dx. Integrate both sides, that's an easy integral. I got my plus c in there immediately. Right when you integrate, put that plus c in there on the side the x's are on. Now, what I like to do is I like to just plug in my port right after I integrate to find that c value. There's a reason for that. I'll share with you that in a second. But I like to stop right after I integrate, take the point that they give me, 0, 4, and plug that in for the x and y to figure out that c value. So I plug the 4 in for the y, plug the 0 in for the x. You see my work there. I was able to get that c is equal to 7. Plug that back in right there. And remember, we always want to get y equals something, y squared equals something, or y cubed equals something. And then so that's why I'm just going to multiply both sides by 2, and then I get that answer right there. Okay, so that's a particular solution to that differential equation. When they give us a point, you got to find the c value and then get that answer. The reason I like to stop right here and get that c value right away, because on an AP test, typically this will be worth 6 out of the 9 points on an AP free response problem. When you separate your variables, you get a point. When you integrate both sides, you get 2 more points. So when I get to right here, I got 3 out of those possible 6 points. And they say on there on the rubric, if you don't find that c value correctly, or if you forget that entirely, the maximum points you can get is 3 out of the 6. But if you could find that c value, that constant of integration properly, that's 2 additional points. So if we find that c value properly, I got 5 out of the 6 points there. Even if the solving stuff gets a little bit crazier at the end, it's a little bit difficult to do, or if I run out of time, I don't have time to solve at the end. If I do the integral and I find that c value right away, I have 5 out of the 6 points on that AP free response problem right away. And so that's why I'm in the habit of just kind of doing that, and I'll stay consistent with that when we do all of our AP review there. But you'll like these problems when we do our AP review. Also on the AP review, we'll probably get the y by itself. We'll probably square root both sides, but then I'll show you when the time is right, how to choose between the plus or the minus there. We don't have to worry about that so much right now. Now, some of you are wondering, why are we allowed to do some of those weird things with that C? You could do algebra first. You could times both sides by 2, right? Now, if you times both sides by 2, you got a couple different approaches there. You could multiply everything by 2, but then you could think, okay, the c is just a constant, so I'm not even going to bother multiplying that by 2. I'm just going to leave it as a plus c. And so I multiplied everything else by 2, and then I plugged in that 0.04, got my c was 14, plugged it back in there. Notice that we get the same answer. Some of you are sitting there thinking, well, that doesn't make any sense. If you're going to multiply everything by 2, why aren't you going to multiply that c by 2 as well? Here's why it doesn't matter. Because look, you could do that. You could certainly do that. You can multiply everything by 2, right? Because then you're going to have a 2c right there instead of the 1c. But when you plug in that point, that means you get 2c equals 14, so you get c is equal to 7. But look what happens when you plug back in that 7 and go 2 times 7, you're going to get that 14. So all you're doing is find the number that belongs in that slot. And if you integrate both sides and put that plus c in there right away, it doesn't matter whether you times it by 2 and get the c equals 14 right away, or if you do want to times it by 2, thinking you're doing legal algebra, that's perfectly fine. But that's just 3 different ways of how we're going to get that same exact answer right there. So hopefully you like the little meatball looking guy there and a little quote there. But solving separable differential equations, practice that worksheet. I got the answers on there for you as well. And then you let me know if you got some questions over that. But when you get stuck, check back at this handout, because these will be helpful. And then there's at least one other problem that's not on here that's very similar scenario. So you got to use your brain and try to model that and try to make those connections there. And let me know if you got questions.